Hello all, here's the Seco Electronics SE2000 DC drive. Let's fire it up and see what it does. Got light bulbs over here to simulate the motor. Looks like it's working. The owner of this drive said that they had no output, but we have output. Let's go see what it looks like on the scope. And afterwards, we'll put a DC motor on it, see if it runs a DC motor. Give me a little bit to move the camera over in front of that oscilloscope. Okay, I'm putting the oscilloscope probes on the A1 and A2 terminal, the armature terminals. I'm slowing the speed down with the speed potentiometer, and now we're completely turned off. Let me turn the potentiometer back up. That looks very good. That's turned all the way up. Turning it down. It's all the way off. We're coming back up. And we're at max speed right there. That looks real good. Let's put a DC motor on it. It's running that motor real good. I can't duplicate their problem here. This drive is working. I'll show you what the waveforms look like with the motor attached to the armature output here. Look at that right there. This is 50 volts per division. Right now we're close to 50 volts peak, and you can see the SCR is firing. Here is the DC applied to that motor. Slowing it down with the speed pot. Now we're turned all the way down. Speeding back up. We're at 50 volts peak. Right here. Nice. That looks real good. I'm going to stop the motor with the start-stop switch. That's a good running drive right there. Okay, folks. Thank you very much for stopping by. Now watch us run that Seco Electronics DC drive. We'll see you next time. Evening all. Now we're going to take a look at the connections to make the Seco Electronics Warner Electric DC drive run a motor. Now the model that I had was SE2105. It's in the SE2000 series of DC drives from Seco Electronics Warner Electric. On pin 1 we have forward, pin 2 we have reverse. Now I didn't go the other way, but y'all can if you want to. Here on pin 3 is start, pin 5 is stop, pin 6 is the thermostat. Now pin 4, according to the manual of this drive right here, SE2000 series, pin 4 is called the start stop. And but it's common between pins 3 start and pin 5 stop. Now I've got a switch over here, and when it is opened, that drive is stopped. And when I close that switch, the motor runs. So I jump pin 1 to pin 3 and pin 3 to pin 4 on this side of the switch. On the other side of the switch, I jump pin 5 to pin 6. Now you can have a motor thermal right here, a motor switch that's normally closed when the temperature is good. If that motor overheats, that switch opens up and disconnects 5 from 6 and stops that motor. But I just jumped it out right here. Now down here on terminals 16, 17, and 18 of that same terminal board 2 that we just looked at is the speed reference input. Now we have the wings of a 2 kilo ohm potentiometer on 16 and 18 and the wiper on 17. Now we're going to look at the power connections. Here's our field on F1 to F2. Here's our motor connection on A1, A2. That's our armature connection to the motor. And here's our line input to power up that drive and run that motor on L1 and L2. Now I applied 220 volts AC single phase to L1 and L2. You have to be careful here. You have to look at your drive because there's a jumper next to the power transformer that selects either 220 volts AC single phase into that transformer or 115 volts AC single phase. Look at your jumper settings before you power up this drive. You don't want to be applying 220 volts AC single phase to that transformer when it's set to 115 volts AC input. You might be making yourself more work than you need. So here we go. On A1 and A2, of course, we have our DC motor connected. Now, when I first tested this drive, you saw that we used 6 series 100 watt light bulbs. And that's fine. I like to do that, and that way I can determine whether that output on the armature terminals A1 and A2 are firing correctly. And then afterwards, when I'm satisfied that everything's good to go, I'll put a motor out there. Now the field on F1 and F2, you're going to have a DC voltage out there. And recalling correctly, I believe I had 104 volts DC out here. It's been a while since I'd tested this drive, but I'm pretty sure I had 104 volts DC out here. Now, our motor has no field, so I left that open. No connection right there.
Now if your motor requires a field, if it has a field winding, then yeah, you want to connect that right there. There you go, folks. I hope y'all enjoyed that video right there. You know, I like working on simple things like this. Well, I take that back. This is a very complicated drive, but in this case, I couldn't find anything wrong with it. I buttoned it up and sent it right back out the door. Now, I have had to go in and work on these drives, and they can get a little bit out there, but every now and then we get lucky and we get thrown a bone, and we don't have to do no work. We just have to fire it up and see what she does. All right, folks. I'm really glad y'all come by, and I hope this helps you to get your Seco Electronics Warner Electric DC drive and motor tested. All right. Y'all have a good night. We'll see you when the sun comes up.